So let's take a look at one like 42H. It's a little different. We're applying the fundamental theorem of calculus part 2. And when we do this, however, we notice both, we're taking the derivative of this definite integral, both the lower and upper limits have variables in them, right? Down here, instead of a constant, we have 5x, and up here we have sine of x. So this is not a constant, so it's not quite the fundamental theorem of calculus part 2, but we see the function we're integrating here. The square root of this is t cubed plus 1 dt. So our variable of integration is t. So I call little f of t the square root of t cubed plus 1. And I'm going to let capital F be the antiderivative. So that means by fundamental theorem of calculus part 1, I can think about this expression as being what? The antiderivative capital F evaluate the upper limit minus the antiderivative F evaluate the lower limit. Now I don't know what capital F is. Okay, capital F is not the square root of t cubed plus 1. And you can't just, there's no simple way to do this one. You can't just write this to the 1/2 power and use power rule, because it's t cubed plus 1 inside of the square root function. So the antiderivative for this function here is not easy to find. Okay, it's not going to be something we want to do. We don't need it though, again, because once I find this, notice we're taking the derivative with respect to x of this stuff. So when I take the derivative with respect to x of both of these expressions, notice they're both variable, they're not constants. And we have to use the chain rule, right? Remember the chain rule, derivative of the composition of capital F with g is the derivative of capital F, the outer function, evaluated at g, the inner function, times the derivative of the inner function. Okay, so with that, what's the derivative of capital F of sine of x? It's the derivative of the outer function, capital F prime, evaluate the inner, times the derivative of the inner. That's the derivative of f of sine of x, minus the derivative of this will be derivative of the outer function, capital F prime, evaluate at 5x, times the derivative of what's inside. Okay, so what is these things? Well, first of all, what is capital F prime of sine of x? Well, remember capital F prime is little f, where little f is the square root of t cubed plus 1. So this is little f of sine of x, and that is going to be the square root of t, which is now sine of x, right? Cubed, which we write as sine cubed x plus 1. So there's that part. What's the derivative of sine of x? Derivative of sine of x is cosine of x. Again, capital F prime of 5x is little f of 5x. Little f, remember the function was square root of t cubed plus 1. So I cube 5x plus 1 and then take the square root. Now be careful, if I cube 5x, that's 5 cubed times x cubed, 5 cubed being 125, x cubed. The derivative of the inner function here, 5x, is just 5. So if I rewrite this thing, I can bring the cosine x in front, cosine x times the square root of sine cubed x plus 1, minus, bring the 5 in front, square root of 125x cubed plus 1. And that's the way you can handle it if both of the limits of integration are variable, and then we take the derivative.